Alright, welcome back to UltraConfig tutorials. Let's talk about RESTCONF today. What is it and why was it invented? Also, how can we use RESTCONF in the real world by managing configuration on a Cisco router? These questions will be the topic of today's video. Before that though, let's do a quick recap on two other options for network management. So, network devices may be managed through several options. Most network engineers are familiar with the CLI, that's the command line interface. The CLI is the most human-friendly interface. When it comes to automation, however, the CLI is not the best choice. For software to be robust, there is a requirement for strict data structures, and CLI commands and outputs are usually just strings of data without much structure. The NETCONF protocol solves this problem. It allows network devices to be managed through remote procedure calls. These RPCs contain well-defined XML messages that are very easy to handle inside software applications. This diagram highlights the major components involved in a NETCONF transaction. Looking at the figure, there are three key takeaways to remember. The NETCONF client sends RPC messages to the network device under management. The NETCONF server running on the device will then interact with the data store, which contains configuration data and state data. The attributes inside the data store are defined by Yang models. If you're not familiar with Yang, check out our video on it. You'll find it on our channel. So with our NETCONF recap out of the way, let's now define RESTCONF. According to RFC 8040, RESTCONF is an HTTP-based protocol that provides a programmatic interface for accessing data defined in Yang, using the data store components defined in NETCONF. Your first reaction might be that it sounds very similar to NETCONF, and indeed you would be right. Check out the conceptual components of RESTCONF. You'll notice there is a great similarity to our NETCONF diagram. In that case, why use RESTCONF when we already have NETCONF? Why have another protocol in the first place? To answer this, we need to think about the trends of the tech industry. It's no secret that businesses all around the world are digitizing themselves through automation. And what is the most popular protocol used in the modern era for automation? The answer to that is HTTP-based REST APIs. And the RESTCONF protocol is available to satisfy that demand. Let's think about it with an example. Imagine a company invested a huge sum of money on automating its business processes through REST APIs. And once that work was complete, they decided to automate their network configuration management. They could easily hit a roadblock at this point. The software they use for automation would need to support the NETCONF protocol. Also, their software developers would need to be skilled up to learn this protocol. You can see the dilemma here. Businesses want to keep their solutions as simple as possible. Ideally, they would use common applications and protocols across their organization. This is where RESTCONF comes to the rescue. It allows users to automate their network infrastructure using familiar RESTful API patterns. Now that we understand the need for RESTCONF, let's do a comparison of some of the key low-level differences between the protocols. Firstly, how are CRUD operations differentiated in a request? That is, your create, read, update, delete operations. The NETCONF protocol specifies the operation by wrapping the message content in an XML tag. For example, you might have a getConfig tag or an editConfig tag. The RESTCONF protocol, on the other hand, specifies the operation using an HTTP method such as get, put, post, patch, or delete. What about data encoding? What format to each use? The NETCONF protocol requires RPC messages to always be encoded with XML. The RESTCONF protocol, on the other hand, allows data to be encoded with either XML or JSON, so RESTCONF is more powerful in this sense. Another key difference is the way configuration data and state data are exposed to clients. A NETCONF client will use multiple levels of depth in an XML message to specify the location of data. A RESTCONF client will use the resource path and the URL of the request to specify the location of data. With all that said, Practical examples are the best way to learn, so let's manage the configuration on a Cisco router using RESTCONF. In our lab, we're running a Cisco CSR router on GNS3. To get started, we must enable RESTCONF on our router. Let's do that now with 3 lines of configuration. We'll create a new user, enable a HTTPS server, and enable the RESTCONF server itself. We'll also need to configure an interface so that we have a layer 3 endpoint for management. We can now verify our RESTCONF server is up and running with a quick curl test. If everything is well, you'll receive a similar response to this one. Let's now discuss the method for discovering the URL path of a resource. If you've studied Yang models before, you'll know that network devices can support multiple Yang models concurrently. These could be native models, IETF models, OpenConfig models. For the remainder of this video, we'll be using the Cisco iOS XE native model. Let's start by retrieving the full running configuration. You can see here that the RESTCONF server returned the full configuration as an XML object. We can now look through the levels of depth to figure out the URL path of resources. Alternatively, we can also read through the source of the Yang models to discover the URL path, but this method is a little more difficult most of the time. For example, looking at the XML data here, we can decipher the URL path for an interface. Let's now use this path to retrieve the configuration of the Gigabit Ethernet 1 interface using a curl command. The configuration is returned as an XML object. However, one of the best things about RESTCONF is the support for JSON. Let's rerun our curl command for retrieving the interface configuration, but this time we will include an additional header. The accept header tells the RESTCONF server we want our response returned as JSON. As you can see, the header did the trick. Alright, let's set one final challenge for the day. Let's configure an interface using a Python program and RESTCONF. First, we need to install an HTTP client. I'll be using requests for this tutorial. We'll now create a new file for our program entitled restconftutorial.py. At the header of the file, we'll import our dependencies. Our router does not have an SSL certificate installed. As a result, requests for our router will produce certificate-related warnings. We can suppress these warnings with a couple lines of code. As we'll be working with JSON, we can also define a function that will print our returned data. Before we configure an interface, let's redo our earlier request for retrieving interface configuration. We can see that our program is running fine. We got back the same config as our earlier curl request. We are now ready to complete our final challenge. We'll use an HTTP request with the method patch. The patch method will tell our router to merge our new interface config. Let's add the code to configure the Gigabit Ethernet 2 interface with the address 10.10.10.1/24. Let's rerun our program. All looks well. We got back a response code of 204. Finally, we can jump onto the CLI of our router to verify the change did indeed occur. There we go, the config looks good. So that's everything essential we need to know about RESTCONF. Before I end today's video, I'll also shout out UltraConfig. The RESTCONF protocol is great at pushing configuration to network devices, but how do you automate the generation of network config? UltraConfig is a powerful piece of software for automating the generation of network config. If you work in the network engineering industry, I highly recommend you to check it out. The software includes an API to fully enable end-to-end network automation. And the best part about it, the software is free to use with our free forever plan. A link to the software will be in the description. I'll also put a link in the description to a written form of today's tutorial for you to try it yourself. That'll be it for today. Thanks for watching, and I'll see you all in the next video.